Alright, hey guys, today we're going to be talking about Unit 3, Circles and Volume. Here are standards, and we've got a little bit of vocabulary before we start the lesson. An inscribed angle is an angle formed by two chords in a circle which have a common endpoint. Here's an example of an inscribed angle. ABC is the inscribed angle in circle A. Here's a quick question for you guys. I'm going to be having little questions for you after every vocab word. So which angle is inscribed? If you answered ABC, then you would be correct. It's inside of the circle here. The radius is a straight line from the center to the circumference of a circle or a sphere. So here, AB is the radius of circle A, and the diameter of a circle is a radius multiplied by 2. And the reason for that is because we've got the radius here, and it's only halfway, so we want to get to the full version. So we're going to cross the circle completely, so we want to multiply it by 2, and it should be there. Here's another question. What is the diameter of a circle if the radius is 5 inches? Now remember, right here, radius only goes halfway, so you want to multiply it by 2 to get the diameter. So basically you want to do 5 times 2, that would be 10. So 10 inches is your diameter. A chord is a line segment that joins 2 points on the circumference of a circle. BC is the chord on circle A. The reason I'm calling them circle A, circle B, circle C is because of the names they've got in the middle here. The middle point is always going to be the name of the circle. And a chord, it can pretty much go anywhere across the circle except through the middle. That would be the diameter. Okay. What segment is the chord in the circle here? Now remember, CD is going straight to the middle, so it can't be a chord. That would be diameter. So we've got to do AB. Circumscribed angle. An angle whose rays are tangent to the circle. What that pretty much means is that we've got the two radii here, and it's connecting to the angle with perpendicular lines or angles. And they're always found outside of the circle, and they only touch 2 points. There we go, we got the same picture here. Which angle is the circumscribed one? We've got AOC or CBA. So remember, it's always on the outside, and it's always touching 2 points, and it's always perpendicular here. So it's got to be ABC. Circles are named by their center, like I talked about. The circumference of a circle is the total distance around it. The circumference is basically the outline of the circle. And here's the formula for it. It's pi d, or 2 pi r, but pi d is basically d is basically r times 2, so. Now the radius is always perpendicular to the tangent where the radius intersects the circle. Now we've got the radius and intersecting the circumference of the circle, and here's the perpendicular line to it. So that should be a right angle there. And that's always like that. It doesn't matter what circle it is. The area. To find the area of the circle, you must have the radius. And here's the formula: A equals pi r squared. And you need the radius because you can't put the diameter in place of this, because it's r times itself, not r times 2, which then we'd be able to use the diameter, but not in this case. Arcs of circles are parts of the circumference. As you can see here, it's taken a little piece of the circumference, and that's basically an arc. And the length of the arc intercepted by an angle is proportional to the radius. There we go. Inscribed and circumscribed angles. Triangle CBA is inscribed in a circle D. And the reason for that being inscribed is because inscribed is basically inside. So that's what I used to remember. So it's always going to be inside, and it's always going to be using little points on the circumference here. And then there's also circumscribed, which is basically the same thing, but it's on the outside. It's on the outside of the circle, and it's going to be. It's always going to be like that, so it's going to be along the circumference. It's going to be outside of the circumference. So basically, that's how I remember it. So yeah, thank you guys for watching. This is my video for math. See you guys